So here today our topic is center of gravity or centroid. Here we can find our figure which we are about to solve. So first we have to determine what shapes are found in this figure. So in this figure we can see the semicircle and the rectangle. So first we have to solve this figure. So as the formula of area of a circle is pi r. So since it's a semicircle, we have to divide to to get the area. So 3.14 represents the pi times 5 meters squared over 2. So 3 times 14 times 5 equals 78.5 over 2. So we have here 39.25 meter squared, because it's known as the area, so we have to specify the meter squared. For the rectangle, we have here length times width. The length times the width of the rectangle is 30 times 15 equals 450 meter squared. So that's it. Then after that, we have to solve the x1 and the y1 of both figures. So here for the semicircle, it is constant that we have that to determine the centroid, which is right about here. From the base, it is 4r over 3 pi. It is constant that this is a constant formula it is constant. So as the radius 5 minus 4r over 3 pi that we can find here, we'll solve this and we have this answer 2.877, or we can round it off as 2.88. Then the y coordinate of the centroid is 15 over 2, which is the diameter. 15 over 2 equals 7.5. While in the rectangle, because we will just cut it in half, the 15 and the 30. The 30 divided 2 equals 15, and this 15 divided 2 is 7.5, as we can see here. But we'll add 5 here because of this semicircle. So x2 equals 20 and 7.5 for the y2. So in solving the centroid, the overall centroid, we'll have to solve the x coordinate of the centroid and the y coordinate of the centroid. So we have here the formula. We'll just have to follow the formula in order to get the final answer. So a1 represents the area 1 and the x1 represents the x1. So we have to put the value on the paper and we'll have this. So we'll just solve this and we'll get 18.63 meter as the x coordinate of the centroid. And for the y coordinate of the centroid, we'll have 7.5 meter as the answer. We'll talk about the axis theorem, and this is the problem we're about to solve. It is, these boxes contains 22 grams and we have 4 boxes, which the distance in each boxes to the center of mass is 6 meters. So first we'll solve the first problem. The summation of the mass of these boxes will be 22 kilograms times 4 of them, and the distance must be squared. So 6 squared times 4 times 22, so the value will be 3,168 kilograms meter squared. Then we'll solve the new using the parallel axis theorem. So we need the answer from the last solving. That's 3,168 kilogram meter squared. There's the other way, but it's much more complicated, but we're focusing on the parallel axis theorem, so we'll use this method. So 3,168 plus the sum of these four 22 kilograms will be 88. Then 9, the distance will be 9 because in this new axis we'll have the center of mass move 9 meters, so we'll use this distance instead of the others 1, the 6. We'll use this squared, so 88 times 9 squared plus the answer from the first solving will be 10,296 kilogram meter squared. So here we'll talk about the composite area. We have here a figure which, as you can see, contains a rectangle, a semicircle, and a triangle. We will have to find the area of these three shapes, then add it together to get the composite area of this problem. So first, the semicircle. The formula of the area of a circle is pi r squared. As you can see, it's a semicircle, so we'll cut it in half and divide it by 2. 3.14 times the radius of the semicircle, 9 centimeters squared, over 2. So we'll get the answer 127.17 centimeters squared. For the rectangle, the length of the rectangle is 23 centimeters and the width is 18 centimeters. 23 times 18 centimeters is 414 centimeters squared. So here in the triangle, we have the formula of 1/2 base times height. So the base of the triangle is 18 centimeters and the height of 15 centimeters. So 18 times 15 over 2, the answer will be 135 centimeters squared. So we have all the areas of these three shapes. Then all you have to do is just add these three. A1 plus A2 plus A3 will be the total area of this composite shape. The total area will be 676.17 centimeters squared. We'll talk about the product of inertia. We have our figure here, which consists of two rectangles, the smaller and the bigger rectangle. First, we have to find the centroid of these two rectangles. As you can see, it is easy enough to determine the centroid of a rectangle because we'll just divide the length and the width by half. So the x coordinate of the centroid will be simply 1000, and the 750 side, the y axis will be the half of 750, which is 375. The same on the other rectangle, but keep in mind we have to add the distance from the origin of the Cartesian. So we have here the half of E1000 is 500 plus the 1000, the distance where the origin and the rectangle. So 1000 plus 500 will be 500 centimeters. Then the half of 750, which is 375, plus the 750 centimeters will be 1125 centimeters. And the area, will solve the area, which is the bigger triangle. We have an area of 1,500,000. Then the second rectangle will be 750,000. Then we'll have to add the x coordinate of the centroid times the area of the centroid will have 1500 times 10 to the 6th power. And for the second rectangle, we have 1125 times 6 times 10 to the 6th power. I have to put scientific notation because we have a lot of zeros there. And for the y, the area of y bar, we'll have to times the 375 times 1,500,000, then 1125 times 750,000, and we have the answer here, 562.5 times 10 to the 6th power, and 843 times 0.75 times 10 to the 6th power. And we have the overall centroid position. We have the x bar of 1166.67 centimeter and a y coordinate of 625. If we graph this, we find the centroid right about here, right about there, yeah, there. And we have to find the IXY. I put 0 here because it is symmetric rectangle, so we don't have to worry about that. And the dx of 166.67, it is negative because here we have just to minus 1. The x coordinate will be minus 1000, and it is negative. Same as the dy of 250, it is negative. And the area of the same as there and there. And the IDDA, we have just to add these two and we have the answer, 187.49 meter to the 4th power. Mass moment of inertia. We have the problem here which contains the graph, a figure of a pendulum with a circle, with a disc and a rod. We have to read the problem. The pendulum consists of 40 kilograms slender rod and a 50 kilogram disc. Determine the mass moment inertia of the pendulum about an axis perpendicular to the page and passing through point 0. You can see the point 0 here, or point O. First, we have to solve the rod, the kilogram by meter. So as the constant 1/12x times mass times length squared, we have 40 kilograms times 0.5 meters squared. Divide 12, the answer will be 8.33 kilogram meter squared. And for the disc, we have the constant 1/2 meter times the radius squared. 50 kilograms times the radius 0.25 squared. Divide 2, we have 1.56 kilogram meter squared. The distance of the rod, which is simply the 0.5 meters over 2.25 meters. Sorry, I forgot to put the meters. And the distance of the disc will be 0.5 plus the 0.25 will be 0.75. I will be 0.83 kilogram meter squared plus 0.25 squared times the 40 kilogram. The answer will be 0.25 squared times 40 plus 0.83 will be 3.33 hundredths kilogram meter squared. And then for the disc, we have the I, which evaluates to 1.56 kilogram meter squared plus 70.75 squared times the 50 kilogram of the weight of the disc, so 18.029 kilogram meter squared. The answer of the both answer, we have to add both answer, so the overall answer will be 21.36 kilogram meter squared. So here's our final answer. Thank you.